Alright, so here we've got this nice area with all these vines in this paddock. Now what do we need to know? For starters, we need to find the length of that diagonal, which we know we can just use Pythag to do, and I'm just going to call it at the moment, let's say D. So we know that's the hypotenuse. So using Pythag, we can get that length is 125. Now if we have a look at each of these rows of vines, if I just put in a 90-degree line there, so they're each 3 meters perpendicularly away from that original diagonal. So if I just label that part A, this part B, and this part C, we can actually get 3 equations with those 3 unknowns and solve for those to start with. So first of all, we know that A plus B has to equal 125 because it's making up that diagonal. What else do we know? We also know that A squared, we've got a right angle triangle there, plus C squared is 75 squared. We also know that B squared plus C squared is 100 squared. So let's just have a look at this. If I subtract these equations, the second one, take away the first one. So if that's the second one, that's the first one. Second one, take away the first one. I am going to get 100 squared take away 75 squared, and I'll do that for you. And here we know that this is just the difference of 2 squares. And remember, we have the addition of A and B already. So if I make B minus A my subject, I am going to divide by A plus B or B plus A, which I know is 125 from up here. So I do know also then that my B minus A is 35. So I also know that. Now, if we put these two together, we now don't have C. So we've got 2 equations and 2 unknowns. So if we add those 2 equations together, we're going to get 2 B's. I'm just going to put it over here. The A's will cancel. And if we add our 125 and our 35, so we're going to get 160 there. And therefore B would be 80. So we know B is 80 now. If I go back to either of those equations and sub in B to get A, I'm going to get A equals, for example, in here, 125 take away 80 is 45. So now I've got A and B. And let's go back to this equation and get C as well. So we've got C squared is 75 squared. And now I'm going to subtract 45 squared for A squared. And square root that as well. So we're going to get C equals 60. So once we have those, we can find everything else we need. So if, for example, C goes all the way down here, and if I divide that, because we know that every 3 meters there's another row of vines, so if I see how many 3's fit into that 60, so that's pretty easy, right? 60 divided by 3, we get 20. So we're going to have 20 rows. So if I call this L1 and L2, I'm going to go all the way to the end, which will be L20. So of course the end is no length, so 0. So I'm going to get this L1, L2, all the way to L20, and I know L20 is 0. And I'm going to get those on either side of that diagonal. So I could also have said this is L1, L2, L3, all the way to L20 there as well. So let's have a first look at L1. So L1, the first diagonal that we're looking at, handy to look at this triangle as having similar triangles. So this triangle would be the same. similar to this one here. So we're in ratio here. So for example, A plus B to C. So the original diagonal we said was 125. So 125 over the perpendicular height of that, which we know is 60. That was C. So if I look at my next similar triangle, that's my L1, or my first diagonal. So over its height, now remember its height is 3 less because we've come in 3, so 60 take away 3 would be 57. And then if I look at my L2, let's say it's equal to also, my next one, so this L2 line now has a perpendicular height of 3 less, so 54. And then I could look at the third one, etc. It has a perpendicular height of 51. So because they're similar triangles, those ratios have to stay the same there. So if we figure that out, we've got 125 over 60 times 57 will give us our L1. 125 over 60 times 54 will give us our L2. 125 divided by 60 times 51 will give us our L3. And if you have a look at what's happening, each time we're going down by 6.25. So it's definitely looking like it's a nice arithmetic series. The first term being 118.75, and remember our last term, if we pretend we're ... we'll go down to the L20, which we know is 0 because that's just right at the corner there. So if I want the total length of all those rows, we just remember that L1 to L20 are on both sides of that diagonal. So if I'm summing the total, so my total rows, I'd be doing 2 lots of my sum of 20 rows because they're on either side of that diagonal, and don't forget the original diagonal, which was the A plus B, or 125. So is an arithmetic sequence, and we've got the first and the last terms there. So we can use n on 2, which is 20 on 2, and our first plus last. And of course our last is 0, so we're just doing first plus 0. And don't forget the diagonal 125. So when we put that in, I think we get 2495 meters in total.